Hey there! So you meet me at the company at a lovely Sunday with a pretty fucked up voice, but that doesn't matter for our today's topic, which is to find the true limits of our Hotend here on the Prusa Mark III. So in the latest video we did some flow tests and pretty much easily surpassed 100 cubic millimeters of flow per second. Look at those spools. But I don't think this is where true limits lies. So what I'm having on my schedule is to first of all run a test with this. There is a 0.6mm nozzle installed and we're gonna run this without the Makita cooling on here. Because what I seem to find out is that we were limited by the heaters in this setup. And this has 100 watts of heating powers combined. And those weren't able to reach set temperature after like 120 cubic millimeters or something on a millimeter nozzle. So let's see where the limits of 100 watts of heating power actually are. And then, if that is not enough, we're gonna overvolt the heaters in here. Maybe it would be a great thing to have, let's say 150 watts installed or something. Haven't figured out how we do that, but let's figure out first if we need it. I also added everything I've got on amperage on those steppers here and lowered a bit of acceleration on there, so maybe we get away with those running as requested. So without further ado, let's just freaking send it. This test will go from 75 to 150 cubic millimeters as a top. We're again using our reference material, which is Fiberlogy high-speed PLA in burgundy color. And as I said, without any cooling, so let's see how far we can push it. Apparently not too far. So this is not really working as I wanted, but if you have a look here, we're way over 100. This one is feeding nicely. This one is skipping. Even we have both of these extruders hooked up in parallel to this tiny TMC 5160. Only one is skipping. Let me investigate. Another day, another rabbit hole. So maybe these two LDO speedy powers are not matched in their parameters for resistance and inductance and whatnot. So I'm gonna change them against these Stepper Online NEMA 17 ones and rerun the test with those and see if they both skip at the same time. Alright, 1 second for you, 1 hour for me. Let's see how this one performs. Same test, same code, same everything, same temperatures. Let's see if we can do this without skipping this time. So apparently not. Again, the right one is skipping. So this is somewhat pointing towards a mechanical issue. Huh. I was fooling around a lot with the burgundy colored material and I couldn't quite recreate the values I had in the last video. Therefore I switched to the black colored one, the actual one we did the tests on. And apparently it didn't make that much of a difference. This is again high-speed PLA by Fiberlogy. And I thought, well, maybe this would make a difference because this is like a solid color and obviously different kind of pigments to it, and this is a transparent one. And after quite some fooling around, I again discovered who is causing all of that, and again we're down to pressure advance. So in the last video I found some mediocre pressure advance settings of 0.12. This is a bit depending on temperatures and flow rates, etc., but this is a mediocre value that is working. And with this kind of values in here, I was being kept at around 115 cubic millimeters of flow. So, and really at the end of this flow test, you can pretty much see the line here. I thought, well, maybe just deactivate pressure advance, and the flow rates kept rising and rising. So this specific one ran through all the way to 150 cubic millimeters a second. So everything in this setup screams for a different extruder setup. The whole reason I'm doing all of this is because I want to make it as available as possible. So these are $15 a piece off of Amazon. I want to get them off to one driver to run this whole thing and make it hassle free. So all of you guys can basically recreate this. But it seems like if you want to max out this system, we're gonna need something else. Pretty much like here on the Minuteman machine with this 4 LGXs. These are geared down quite a bit. So all of these peaks that require a lot of torque, I'm pretty sure those would handle. I debated with myself if I should take 2 of those off of here, but I don't want to mess with that setup because this is what I will be dealing with in the next video, and I don't want to leave myself to some construction site here. Basically like here on the reality machine again. So I think my quest for a good extruder is the next logical thing, and as I said in the last video, I'm gonna be making a prototype of something that is based off of one motor and that is either going to be linked by belts or gears. I haven't fully settled on this. But then we can have the best of all of the worlds, have a sophisticated motor that is not like parallelized to one driver. We can gear it down quite a bit, find the perfect ratio there, maybe somewhere in the 1:5 range, and then we can finally max this out, I guess. Let's shortly talk about 2 things, which is how you can acquire those parts and the sponsor of today's video, which is PCBWay. So PCBWay has been offering these parts here for my prototyping endeavors for this whole journey here. All of these are made from aluminum. This has been 3D printed in stainless steel, and have a look for yourself. The quality is just outstanding, and the price point as well as how fast I get them on my hands is just really, really good. So you can download pretty much all of the files for this exact Hotend or the 4X version on my GitHub page, which is linked down in the video description. And there's also a drawing which is specifically made for PCBWay. So you can basically go on the PCBWay website, which has all sorts of manufacturing goods, starting from PCB manufacturing, over 3D printing, of course, in all sorts of flavors, but also sheet metal design, 5-axis, CNC machining, etc. And you can get those by uploading the STL or step files in the unmachined version, or you can upload the technical drawing and get these fully machined with all the threads and tolerances in the part. So again and again, thank you so much PCBWay for supporting me with all this crazy stuff here. This is exactly what I need to develop these projects and making this open source available for all of you guys. And it is as always. Manufacturers do claim numbers for the products, but in the least amount of cases they give you like all the surroundings, all the parameters they use to actually achieve those values. In my case this is different. I don't want to sell you anything, I just want to give you the opportunity to build it yourself and fool around with it and probably make some money with it or whatever you want to do with this kind of setup. So I think we're going to divide that into 2 categories from now on. First one will be, as seen in the last video, with the proper pressure advance values you're going to be needing for having crisp and really clean, intricate prints. You're gonna be maxed out with this kind of Amazon extruder setup at around 120, maybe a bit less of flow on a good PLA. I haven't checked any other materials. That is going to be done in future episodes, or you can do it by yourself. But maybe if you're just interested in numbers in your prints and want to go as high as possible because this is where your profit is lying, you may be getting away with low PA values, or lower as in this case, or probably without any of these, or probably you don't have a machine that can do pressure advance or something. I'm gonna be rerunning this test now, find proper temperature curve for doing all of this and really max it out on this kind of setup, and we can see where we're going with this and conclude our testing for today. So with this kind of system, I'm basically trying to catch my own tail. Have a look here, I just discovered this a few minutes ago. I flush cut these here, and I'm gonna command to extrude 200 millimeters of filament, so 100 is gonna come out of either tube, and I'm gonna flush cut them here again at the exit of the PTFE tube. First extrusion on 0, and this comes down to 89 millimeters, and the second one is at 101, maybe 102. So on average, this comes down to the requested amount, but sure enough, we are very likely to get some uneven pressure inside of the nozzle. And I fooled around a bit with the pressure the springs give on the extrusion system, but this didn't seem to make any difference. So this is basically due to manufacturing tolerances, I guess. One of them will have a larger circumference as the other. We're just gonna have to live with that in this kind of setup. So if you've watched my videos before, you know that I can get quite obsessed with things, just as these benches here, you know? But for the last couple of, let's say, 2.5 days, I became obsessed with maximum flow tests. So yeah, this has been driving me a bit more insane than I already used to be. So let me try to get you catched up on speed. So what ended up happening again and again is that the right extruder started to either skip steps in the beginning or later just grind the filament when I upped the amperage. And I literally did everything in case of trouble solving to pinpoint down the issue. And I think I got a verdict, but yeah, let me try to explain. So at the very beginning, I had this exact extruder in mind, and I was fooling around basically with how these gears are aligned, etc. I was doing pull tests with a scale, and when I had the final version where everything was up to speed, etc., it started grinding again. All of these tests were done, let's say, from 75 to 150 cubic millimeters a second. This is where I want to end up. Then I blamed the motor currents, and ultimately I settled on this here for testing, and I had both of these hooked up to a single driver here and was maxing out the amperage. We do know that we can't run pressure advance on 2 channels, but yes, since I figured let's do it without anyways, I could do it like this. I could also get rid of the error in the extrusion rate, so basically both of these are individually matched in flow, but still was always the right one that kept on skipping. And I got off to a crazy witch hunt what this is all about. So I was checking temperatures with the thermal cameras. And I basically found out that I was running these heat cartridges, which basically came from 2 different batches. You can see that these are a bit different. And I was starting to think that the right-hand side of the hot end is getting low on temps, and that therefore the right channel was getting less performance. So I changed these out, put them back in with a load of thermal paste, rerun the tests, and ended up getting the same results, even though like the ones that are in now are also like resistance matched to a close degree. So these are within, let's say, 2 or 3% to each other. Still, right lane. And then ultimately, I could narrow it down a bit more when I switched these 2. And then the left one started grinding or skipping. And yeah, this was the first hint at what I think is going on in this system here. Because in all of these tests, even when I was just running it all the way to the end, the, let's say, one on the left lane did work properly. And all of these, which I had been running all the way to 150 cubic millimeters, not a single skipped step or grinding occurred to this, let's say, the left lane of the hot end. And then I started to do weird stuff. I have no idea how much of that footage I got, but I put this LDO orbiter on the right lane because I thought, well, with the gear reduction and proper gear tooth, which are made by Bondtech, I thought I could get away with it. Ultimately, I was kind of stuck in the 125 cubic millimeter range, but still left one was going. Then I built this crazy contraption. I do have a very short clip of that where I had like 2 of these built on top of each other. Well, yeah, that was a failure. I think I've seen someone's video about putting extruders in series, but what ended up happening is that once the upper extruder was actually losing a step, the lower one was just shooting filament in its butthole, and that wasn't working either. So I finally came back to this here, did a bunch of testing, found out a lot of different stuff about it. So for example, when I was running these at very high currents, the extruders got quite warm, and when they reached around 40 to 50 degrees, grinding the PLA filament was becoming way more easy for them. So yeah, basically I had to cool them after runs. And I wouldn't have been so obsessed with it if there weren't a few where I actually got up to 145 or something, which was looking really, really good. So I know this system has a lot more in it than this complete setup is able to deliver. So of course I still do have the bottleneck of cooling. You can see the very top lines here. This is cooling. I could squeeze this really easily when I took it off the build plate. But now, if you want to go big numbers on a very small and light hot end, extruders seems to be the new bottleneck. Of course, who would have thought? But yeah, my keep on going was fueled by these results here. This is looking awesome. And I think if we got a proper extruder setup here, then I can make it work. And it will break all records for this kind of a small setup here. This is the important part of what I'm trying to build up to. I have two things planned. So first off, I wrote a mail to Bondtech and asked if they will be sponsoring 2 LGX Pro units here. So basically the same I've been running here on the Minuteman machine, exact replica of this, just with 2 for this setup. And these extruders have been super reliable to me, and also you know how often I've been praising them. I was running them at 0.5 amp or something, and they just kept on pushing and pushing and never really ground or skipped a step or anything. So I want to try that with some industrial standard components that are up to the task and see where we end up. And now, and this is even more important, and I got goosebumps saying this because left lane is up to 150 cubic millimeters with this kind of setup. This is $15 a piece off of Amazon. So what we will be doing is send off this exact hot end to get an X-ray scan on it. And we can see where are the differences between left and right lane and learn from that. Is it diameter? Is it surface roughness? Is it whatever? Let's try to find out. With these kinds of results, maybe we can get 2 left lanes basically in our next iteration and keep bumping those numbers up. So usually my videos tend to be on the really long side of YouTube. This time I restrained myself. So we're gonna do a cut here. I could wait all the way, like all the companies are busy right now with holidays. So it would take me a week to get those Bondtech extruders here, set everything up, do all the tests again. But I think it is smarter to post this now. The further I upload my failing, the more you can enjoy the process of building it and having it work out of the gate. Last but not least, I cannot emphasize enough how good it is that we finally fixed the leakage problem. Nothing has come out of these heat breaks there. And this is really a big step forward into making this a reliable product. I've been fail testing this to a really big extent. At one point I completely forgot to put in the right one. It was just dangling around here, and I noticed after 30 seconds of printing or something. So with this 0.6 millimeter nozzle, it is absolutely bulletproof. I have never had a clogged heat break or something again. I could push the filament in no matter what I did before. And now, really lastly, thank you so much to my patrons. You guys and girls are enabling me to buy all this stupid stuff that goes into these projects and keep doing what I love in my free time. So, thank you so much.